Welcome on the channel. In last video about electronics I built such a valve tube variable stabilized high tension or high voltage, high tension power supply unit, and of course I explained which element I fit and why, but we don't talk about the design, so today will be just a tech talk. Of course it was a lot of mumbling, so this is for people who are really interested in it. I will explain how to design this main module, but we don't touch the don't touch the curves of the tubes, because generally it works. If you take the proper element, it works. You have just calculate few things, so you don't have to understand to the end. Of course, if will be people who are interested to get this information, go deeper, I will try to explain this part which are also not understand to the end. And today we concentrate on this main module, what we have to calculate and why we have to calculate. I don't touch the supporting module, it means external additional power supply to powering the meters, and I don't touch the situation so these heaters have to be elevated or powered from different transformers. And of course we don't talk about like a main transformer and bridge. It's I know everybody knows how it works. Okay, so a lot of mumbling about theory. Let's go. Okay, dokie, let's go. So generally, to clarify, our power supply, this is piece which deliver us DC, it means transformer and bridge. Then we have this main module itself, plus let's say supporting, let's say module anything. And here we have our variable output. So our main module itself looks like something like that. So this is pass element or component, error amplifier, voltage divider, and voltage reference. So let's translate it for the on the language of modern electronic for something more ancient. So we have very simplified diagram of same with just thermionic valves or tubes or whatever you call. So we have pass element, error amplifier, and voltage reference. This diagram, let's say it will work, but it's too simplified. So basic of the basic how this work. So voltage reference element hold the cathode of error amplifier at a certain voltage above the ground. And let's say voltage output rise because of, let's say, changing in load. Voltage rise is change the voltage of voltage divider here. So means grid of voltage amplifier became more positive. So grid became more positive. It increased the another current of error amplifier. So means it's biased pass element more negatively, and because of that lower output voltage. What we can use as a pass element. Of course, we can use tubes that are dedicated for working for inside the power supplies, like this 6S19P triode. But quite good are also different tubes, maybe not straight dedicated to this, but is, let's say, this is PL81, could be EL81, or this PL504, or this 6P44S, or if somebody wants a octal system, can be, let's say, PL36 even. It's not the best choice, but is. But what is interesting, we can also use very common and very cheap valve as a PL84, or with different heater will be EL86. It's the same valve. Of course, all these valves we use in a as a triode connected, because here we have some loss on the voltage across the valve. So if we use triode, this is like a less internal resistance, less we lost. Second main component is a valve amplifier, and usually we can use such a valve as EF80, also very cheap, very common, and besides its works is not perfect catalog conditions, it works perfectly, and if we have to replace after some time, come on, got out. Is quite cheap. Or second very common is EF184. To tell the truth, this is successor of this valve. Or even, let's say, every pentote we can use in this system, in like even small F95. Next component, this is voltage reference. Here on the diagram I have neon stabilizer, something like, it should be neon reference stabilizer, something like that, or it can be like, I don't know the name right now, but it keeps at 85 volts. We can use also such a small piece like a TAA 550 from Mullard. It's under many names. It's not Zener diode, this is IC inside. Or we can use the Zener diode this is what I have. It's a ZX43, so this means 43 volts. With Zener diode is a kind of problem because they require a bigger current for properly working. Okay, so we have the main components. Of course, on the diagram here I showed it simpler tube, not pentode, just like a triode, just to simplify the diagram. Later on we change it for pentode. Of course, it's some limitation on, like on everywhere and on every design. On this pass element, so means pass valve, we lost some voltage from cathode to anode. So for this reason, like I said earlier, we use intriode connection because internal resistance of triode are much lower than resistance of pentode, so we not lost so many voltage. It's not about we lost. We have to dissipate this power from lost voltage from the valve. So this is kind of limitation, but of course the maximum dissipation of valves are very different. Let's say this have probably 11 from what I remember watt, and this king of the power supplies have, from what I remember, 21. So when we go with regulation from, let's say, on input 350 and we're gonna wanna go to 150 on the output, we have to dissipate here 200 volts times our current, let's say 100 milliamps. So times, so it means 20 watt. So this is 20 watt we have lost as a heat on this pass element. So for our point of view, lower resistance, it's better. Second limitation, this is like a lower adjustment voltage, because we have to consider the voltage reference plus voltage we kept between anode and cathode of error amplifier plus steering voltage. It means like a driving voltage. It means bias of grid of pass valve. So in case of 85 volts from voltage reference, probably we cannot go down below I think 165 volt if you check on the curve, something around. Of course, if we use such a small detail, this is 33 volts, so let's say we can go even up to 115 volt in this case. And same concern Zener diode. This is 43, but of course we can found for 33 volts also. So this is one thing what we have to remember. So this is more valve and more fancy because this is on valves, etc., etc. But we lost something, and we have to remember. So in the end of the range of adjustment, the stabilization is much worse than somewhere in the middle. So because of that we have to remember about it, and this is one of consideration we have to make when we designing something in this. Like I said earlier, you don't have to fully understand how it works. It will works. You have just to understand the basics. Of course, if anybody will be interesting to get deeper knowledge, I can make a special, let's say, video when I try to give some advice how to read something from this famous valve curves and get some information about it. But to tell the truth, if you operate with these components which I show, it means like this pass valves, this error amplifier valve, and this reference voltage, it will work without minimum knowledge. Of course, you have to calculate something. So let's complicate our diagram a bit. So because we cannot go with bias of amplifier below the voltage reference, it's reasonable to split this into three pieces. So we have, let's say, R1, R2, well, let's say R2, maybe later on I changed it, and potentiometer inside. It's a few things we have to calculate, only a few, and maybe two of them are the most important. So we start from the simplest. So we have to calculate this resistor, which limited the current going through reference voltage source. No matter it will be this, or that, we have to calculate it. Like I said, this resistor limited the current going through voltage reference source. So is simply because we know so this. The current going through, okay, let's say this tube we can found in datasheet. Same concern Zener or this small, let's say varicap Zener or something like that. We can found in datasheet. So it looks simply. Of course, we have to remember. So this voltage are vary. Let's say if we wanna keep the changes between 300 and 200 volts, we have to choose this voltage, this resistor, to be in a range of current good for this element, for this voltage source. For example, for neon tube, the current is usually somewhere between 1 milliamp to 10 milliamp. For this IC TAA550 is usually between 5 milliamp to 15 milliamp. And we have to remember, so with 15 milliamp we have to dissipate this power somewhere. Yes, and for this ZX43 Zener is 10 milliamp up to 25 milliamp. Even more, this can, with heatsink, it can go much higher, but problem always with dissipation from this element and also from this resistor. And from experience, not only mine, it shows so this Zener require rather higher current than lower. So of course with neon tube we have the smallest current, smallest resistor here. With this we are same around, because we never run it with 1 milliamp, we always choose a bit more. And with Zener diode we have used the biggest resistor, it means in watt of these three elements. We choose, let's say for TA550 we use 5 milliamps. So we have V out 200 minus 33 volts divide by 5 milliamps. So we have resistor in ohms. Power we lost on this resistor will be just 200 minus 160 volt across this resistor. 100 multiply by is 0.83 watt. So means we should 1 watt is maybe not enough. 1.5 watt will be the best, but we don't have 1.5 watt resistor, so it here should be something like a 2 watt resistor in this place. So in case we choose the Zener diode even with this 43, probably we have to fit here 4-5 watt resistors. So you can calculate it. I don't want to make it longer, but this is what we have to do. And of course, when we go up, the current will rise. When we calculate at 300, it means, but the resistor will be same. Current goes up, so it will be probably something like 300 volts divided by 3. It will be around 9 milliamps. So with 9 milliamps of current, power which we have to lost on this resistors will be 267 times it came to 2.4 watt. So we see, so in this case we have to lost and to 2.4 watt, and means we have to fit at least 4 watt resistor. So for this reason, for us it's much better to use this small TA550 or neon tube than Zener diode, because with Zener diode we have to start thinking about big chunky resistors. Of course, everything depends what we have in our drawers, because maybe we have in the drawer a lot of stock of power resistors, so it will be easy to think it. So this is the calculations what we have to make for this resistor, and this is and next it will be about the brain of the system, so it means voltage divider. Okay, we know, so we cannot go lower than this voltage reference with this. So for calculating, we together. Like usually, we have the problem with power dissipation, especially on this not trim pot, just potentiometer, because it's hard to get something chunky enough and cheap to carry big power. So we have to try to minimize the current in voltage divider, especially so we not need any current here. It should be no current. This is just potential here, error amplifier. So let's say we said, so we wanna run it at 1 milliamp. R1 1 plus R2 is our output voltage through this current. So if we want to use in the highest point 300 volt of the range, so our voltage divider should have 300 kilos, just 300 volts. Okay, 300 divided by, I don't know, is visible or not. Okay, we came with results of 300 kilo ohms for full voltage divider. So starts dividing into the pieces. So for R2, so because our output voltage will be changing, let's say from 200 volt to 300 volt, it's obvious. So this bottom leg of our divider have to be set for lower value. So we get like two values. The problem is, so we change the voltage, also it will change the current through voltage divider. So this is a lot of kind of calculations, but it should be checked in a practice where we are and make some adjustments. So we use this lower value for a R2, so it will be 3 kilo, and for 200 volts it means this difference between 39 and a half and 33 kilo is our potentiometer. The problem is, of course, not only in changing the current when we change the voltage, output voltage, but also with components which we can get. Because right now our trim pot, it's not trim pot, should have something like a 16.5. I don't think we can buy the 16.5 potentiometer. We can buy 20, 25, something like that. So we have to recalculate everything few times. But when we change the value, legs of voltage divider, we also change the current inside the voltage divider. So it's a not short story. So later on we came to such a 100,000 calculations to reach the value what we can use it. Here, for example, I calculate few times and I reach the value of 22 kilos, or because I suppose I have such a pot in a drawer. And finally, when I start measuring, the spot shows, so it's not 22. It's only written on it 22, but it was 24.5. With resistors, we can also always assemble resistors with like connecting them in parallel, etc., and it's okay. But with pots is much worse situation, so we have to calculate it few times, and finally we have to check it in practice. Okay, so that was about this calculation. I'm not pretty sure it was clear. If you have any remarks, leave it inside the comment section. If you have any question, I will try to explain it, because this part of this system I did few times and I hope I understand it quite well. But also I all the time can make mistakes. And like I said on the beginning, you don't have to fully understand how the system works. It works. You have just calculate two things. The most important, this is this voltage divider. This is really important part of this system. And here is no space for it's no margin, no room to play with these values. These values have to be rather accurate, because other way you're going below the stabilization range, so it doesn't make a sense. And second, this is just this resistors for voltage reference we choose, and in other parts we can just belong on schematic we can find into internet. Till this moment I not talk about how to use the pentode in a error amplifier. It means we have to power feed the voltage inside the second grid of this. And it's a few options. All options work more or less. No, they always work, just in better and worse situation. Okay, depend on the output voltage range of our power supply, because it's a bit different situation if we wanna go from, let's say, 120 volt to 350, and different situation we wanna go from 100, let's say 70 volt to 300, or even from, let's say, 200 to 300. Because if we have smaller, much narrow range, we have more options. It means, because we have to remember, so we have to keep the second grid of voltage pentode in voltage error amplifier below the another voltage of this. So in case when we're talking about this, let's say, lower ranges, a bit, yep, lower ranges, we have to keep it around the VG2 should be around 100 volts. Definitely not below 90, because I don't know, it does not work. So always you can make some experiments. This is not silicon chips, you know. In this glass the magic smokes are kept much stronger. So anyway, so in this case we can power this through just voltage divider. And we can make this voltage divider on this side or on output side. But on output sides is a problem, because when we lower this voltage, output voltage, this voltage goes down. So in one moment it became not stable, even stops working properly. So much safer way is powering it from input. Some people claim so this is some kind of, so everything depends on the range. If the range will be from, let's say, 200 to 250, because of some reason we need such a power supply, we can do this, because we can set the voltage divider and it will change the voltage in a smaller range, this which we fit into the G2. But in these two ranges I prefer this. Of course, let's say we can use something like also, instead of this we can use second neon tube, let's say for 108 volt. Why not? Yeah. But in case we go to the very wide range, we have no chance, because always sometimes we cross this proper voltage, so we have to do different system. So we have to use something like that. It's not proper, it's not like the best way to do it, but we have no choice, so we have to do something like that. So we just feed the resistor which limited the current and powered this grid from the output voltage. Of course, in this case this grid are quite high, it's a bit too high potential and it's not comfort, but as practice show it works. One of my power supplies, you never have too many power supplies, it works in this style and works. Of course here should be capacitor also. Works and works quite long. From time to time I have to replace the EF80. So this about just pentode. And okay, to simplify I make some drawings. Okay, so biggest range, let's say from 150 to 100, and it's not depend on the voltage itself, it's depend on the range. It's not, I make a few drawings to clarify. Okay, so it's not about voltage itself, it's about between range. It means difference between lower and highest output of our power supply. So for the biggest range we have to power it like that. It means through like a limited resistors from the output voltage. From the middle range, let's say, we have to use a voltage divider. From this side, or try to support it by neon lamp. And on this, if this range are definitely smaller, we can just use the voltage divider from output side, and it will be the best from different things, different point of view. Just to summarize, because for sure I lost somewhere in between details or too many details. You don't have to understand fully how it works. It works. For if anybody, let's say few people, ask me to explain, deeper, I will try to prepare the video with deeper explaining. Okay, but what we have to remember, what we have to calculate is voltage divider, this is the most, limiting resistor, voltage reference, 4 voltage reference, 3, voltage divider, 4, error tube, so it means FAT in our case, 100, 115 volts. I suggest is everything depends on the range. You can make some experiments. This is thing. What we have to remember. We have to remember so this stabilizer needs some load almost all the time to work properly from switching off. So I think minimum is at least 5 milliamps of current will flow from all the time, maybe 10. I prefer this higher. So if our voltage divider plus limited resistor together give us less than 10 milliamps, just we have to add some resistor with preload which are keeps the current flowing. Fifth, output cap, something between 4 to 10 microfarads. This is maximum. In the rest you can follow this diagram which I include in earlier previous video. It's proven, it works, so that's it.